Thank you for attending our third session in our seminar series, Woodworking for Inventor. My name is Steve Widom, and I represent Widom Associates. Today's session will center around the usage of miter folding in the wood industry. Inventor, as a solution for design to fabrication, is a wonderful tool that will allow not only novice but the most advanced users to get the most out of the possibility of the utilization of this method. Miter folding is an innovative method of mitering the edges of two or more sections of almost any material, or either pre-laminated wood sheets at any angle. The goal is the end result will have no visible outside seams, giving a solid one-piece appearance to the finished component and continuous wood grain. Miter folding is a manufacturing process that takes a laminate or wood veneer that has been glued to an MDF core or particle board or plywood, and then processed through a CNC router or V-groove machine that creates grooves that allow the part to be folded up. This process allows the fixture to be fabricated without any unsightly brown lines, eliminating exposed edges and seams while enabling the cost savings of up to 30% on a fully manufactured part when compared to manufacturing using traditional methods. Our goal today is to provide methods and solutions to fellow woodworkers so they can take advantage of this process. Several years ago, I was asked to do a presentation on miter folding at one of the workshops. At that point, because of the earlier releases of Inventor, it was not as capable as it is today. Today I'm using Inventor 2018. Whether it's professional or premium, it doesn't matter. In fact, this will work all the way down to 2015, I do believe. And of course, now that 2019's out, again, it will work with 2019. The method I'm going to use is solid body modeling, because the end result is still going to be a single part that we want to machine. The first type of miter folding I'm going to do is a straight 45-degree miter. When we start out, we have to make certain decisions, and I would say the most important one is the ability to be totally variable with information, so that whatever the condition comes about, we'll have the capability of changing it, modifying it, manipulating it. So I'm going to start with 3 rectangles. And this will simulate the end grain, looking at the end grain of a single board. Now, because I want to change it, and I'm going to use some iLogic here, I'm going to say thickness equals nominally 0.75 or 3/4 of an inch. I'm going to type in leg 1 equals, say, 3 inches. Leg 2 equals 3 inches. And leg 3 equals 3 inches. So there'll be 3 sections that will be folded on each other. That is the intent. I'll look at it in an isometric view or home view, and then extrude, let's say leg 1, and we'll say length equals, let's say 12 inches for the moment. I'll click on this and share the sketch and extrude, flip it the other way, use the parameter length, it's a new solid, and pick OK. Then extrude the final one, or leg 3, to length also, and pick OK. So what we have here are three individual pieces of material. Well, really, they're not individual pieces of material. It's three separate solids, but it's one part. As we can see here in the browser, there are three solids, 1, 2, and 3. One part. I'll also start now adding my angles. So I'm going to say chamfer, edge 1, and we'll chamfer it to thickness so that it will be equal to the thickness of the material, and pick apply, edge 2, and apply, edge 3, apply, and edge 4, and apply. And you can now see that we have three separate solid bodies with 45-degree angles. And of course, those are the ones that are going to be folded on each other. If I wanted a true box, then I would have done the outside and probably added a fourth leg. I'll turn off the sketch, the shared sketch, in the browser, and pick Save. And give it a name. Let's call this Variable Miter Fold, and pick OK. My next step is to control what's going on here. So I want to control each of the legs, different lengths. I want to control the thickness of the material, and I want to control the length of the actual item itself here, the part. There are three solid bodies here, as you can see, and they're called solid 1, 2, and 3. Of course, I could rename them leg 1, leg 2, and leg 3. Again, your call, based on the way that you might be using Inventor today. But I do want to start managing this, okay, developing, utilizing it, because once I have this, it's going to be a library item that I can pull and utilize at any time for any project. So I'll go into Manage, and I'll go to iLogic, and the iLogic browser pops up. Sometimes the iLogic browser is sitting right on top of the normal browser, so you can see that you can toggle between the two. Now, I'll pull this out of dock so that we can work with this. I'll go into Forms, right-click and add a form, and you can see here are my variables that I was using previously. So if I highlight my variables and drop them, you can see that what has happened is I now have a dialog box that will control each of the items. Now I'm going to clean it up a little bit because I'm not comfortable with the way it's presenting. So I'll move thickness all the way down. I have leg 1, leg 2, leg 3, length and thickness, and I'll put a splitter after leg 3. So it looks a little bit better. And I pick OK. Once that's done, I'll now have a dialog box that will allow me to change things. So if I want to change leg 1 and make it 5 inches, it's now 5 inches. Leg 2, 2 inches. The length of it is 18 inches. And the thickness of the material, let's say, is 1/4 of an inch. Okay, so all of that is working just fine. And we'll just put it back for the moment. Move it back to 12 and move this to 0.75. Once we have the actual core modeled, which are this one part that will have 3 legs, we now have to fold up one leg against another, or one solid body against another. The way it's done is simply using Direct Edit. The Direct Edit tool is found under 3D modeling, introduced number of versions ago, a wonderful tool, and I use it quite often to accomplish tasks that were much more difficult and only could have been done in an assembly. So the first thing I'm going to decide upon is which of the parts is going to be a stationary part, or I should say which of the solids are going to be a stationary solid and which are going to be the movable solids. So in this particular situation, I'm going to just indicate that the middle leg will be the stationary solid. So I pick direct. I'm going to say I want to rotate something, and I'm going to rotate a solid rather than a face. I'm going to touch the solid that I want to rotate. I'll look at it from front view, and I'm going to locate the rotation point right at that vertice. Once I've done that, I can move my mouse onto these dashed lines, and they will allow me to then just pull with my mouse so I can see I have correctly selected, and I'm going to type in the value that I want and pick OK. Now that value can be a variable, and I can control it if I so desire. I'll go ahead and do exactly the same thing with the other piece. Locate the vertice point and rotate that 90 degrees and pick OK, or hit the plus sign. If I'm done with this, I can hit X and I'm out of the system. Now, to test this, over in the browser you now have something called Direct Edit. If I right click on it and suppress it, it's going to open it up. So you start getting an idea of why I'm doing what I'm doing. If we go ahead and unsuppress it, and we change the thickness from, let's say, 3/4 to 1/4 inch, you can see that everything works because I'm using the variable thickness on those chamfers. If we go ahead and unfold it, like we've done before, and then it's correct. If we change the leg, let's change the center leg from 3 inches to 2 inches. Let's change leg 1 to 4 inches. Let's change leg 3 to 2 inches. You can see that I am changing everything. And then if I want to unsuppress the feature, it is correct. In fact, if we take leg 2 and change it to 1 inch, let's go further with this, or change leg 2 to 0.5, I've folded it on itself. This is one of those methods that we use when we start building with miter folding, because this is a seamless edge. How do I know? Well, you don't see it when everything is gray. Let me save my work, and I'll go into Woodwork Design, and I will assign some material to it. Let's assign bird's eye maple veneer to this. So when you look at this now, you can see that this is a continuous edge. Okay, wire edge, no seam, meaning thick seam for edge banding or what have you. And again, if you change leg 1 to 1 inch, okay, or 1 inch, sorry, you can see that this seam works out very, very well. This is a standard 45-degree miter fold, but we have many other options of miter folding. We have LOC miters that we could implement this way, curved LOC miters, spline LOC miters. So it really is not too many limitations. So what I like to do is show you sort of the method that we can implement around now taking a simple miter of this nature and enhancing it even further. Okay, so the first thing is what I'm going to do is put this back to a pretty straightforward 6 by 6 by 6 box, and I'm going to unfold it by doing suppress the feature, and we're going to come back to that also in a little bit. So what we have here now is the end grain, and I'm going to now consider the possibility of putting in LOC miters. Now, to create our LOC miters, to start adding a little bit more surface area for gluing or for registration, it's fairly simple. Depending upon, again, what your particular company does or what your design does, whether it's a decorative design. I've seen S-curved LOC miters, if that detail is going to be shown. There's variations of what one can do. What I'm going to do here is I'm going to get started by creating my positive and negative shapes. So I'm going to create a sketch, and I'm going to draw a line from the midpoint. You can find the midpoint like so. And I'm going to extrude just that piece, and I'm going to cut all the way through the part. I'm going to come over here. I'm going to sketch on this piece. I'm going to draw a line from the midpoint across and up. And the reason I'm doing that is because I want it to work no matter what the thickness of the material is. So I'm not even giving it a dimension. All I'm doing is saying midpoint to corner point. I'm going to cut, distance is all, and pick OK. So now what I have are the two outside edges. Now let's do the insides. If I go ahead and sketch on the inside, and let's draw a line from here, find the mid, pick, and do exactly the same here. And let's go ahead and rotate this around so we can see what I just did. Extrude this. I'm going to extrude this piece and that piece. I'm going to flip it the other way and tell it the variable length and pick OK. So these should lock into each other. Now the method that you use here, or whatever the sketch is, that's completely up to you. Let's unsuppress the direct edit. So you could see that here are the last extrusions, the two cuts, and the one join. If I right click and I unsuppress the feature and pick, oh, something's happening, and pick accept, okay, you can see that there is some variation here that doesn't look right. And you also notice over here that there are some exclamation points saying that there's some problem. Well, because we did these after it's been folded, that's where the problem comes in. But if we take these last extrusions and move them up above direct edit, this is all cleaned up. So the order in which you do it is important, and this is just one way to accomplish that task. If we go back to direct edit and unsuppress it, you can see that that works just fine. I'm going to take this face and just change the appearance so it lights up a little bit differently. Let's make it black. Sorry, let's change that face and make it a different color. Okay, unsuppress. Let's change this a little bit. Let's make leg 2 inches. And you can see that what's happening here. And now we have a LOC miter. I would now like to add the parameter for folding and unfolding right inside of this dialog box. Because again, I'm going to want to use this as a library part where I can bring it in tell it I want it folded, unfolded without going to the browser, so that every one of my every one of my team members can then take advantage of this tool. So right now, this is called Direct Edit 3, and maybe what I'm going to do is call this, okay, we can give it a different name if we want. We can call it Layout. Give it any name you want, okay? So if I right-click on Layout, I can suppress or unsuppress. Let's now go into parameters. Okay, so let's come back into modeling, go into parameters, and we could see here now what we've been doing. Okay, so thickness, leg 1, leg 2, leg 3, and length, of course, are options here. And what I'm going to do is I'm going to also make them key fields so that they will be able to be used downstream and be prompted for, whereas all these others maybe aren't as critical. But again, this is a choice we can make. What I'm going to do is add a text field now. And the text field, I'm going to give it a name. I'll call it pattern. And it will be, I'll give it one option called fold. I'm going to right click and make it a multi-value field, and I'm going to give it another option called unfold and pick OK. So now what I have is a parameter called pattern where it's a text field, and there's two options, fold and unfold. Again, case sensitive, be careful here as we go further. Usually part variables I use lowercase, and global variables or assembly variables I use uppercase, but again, whichever makes the most sense to you as you're working through it. If this is the first time you're seeing this, lots and lots of tools. We've done many iLogic presentations in the past. I'll pick done. Okay, and then if I go into iLogic, go to forms, edit the form, bring pattern in. You can see it's now here. Let's put a splitter above pattern, and let's give the form a name, and let's call it Miter folding. And pick OK. So now you can see it's called Miter folding, and what we have here is, of course, an option for fold and unfold, but it's not connected to anything yet, so it's not going to do anything at the moment. Okay, the next step is to develop a rule associated with this new parameter. So we'll go into iLogic, into rules, right click, and add a rule. And I'll call it Miter fold and pick OK. So at this level here, we've done many iLogic presentations, so the simplest way of doing this is use an if-then statement, and I'll say if my expression, which is pattern, that's the variable name, equals one of the options was fold, okay, and lowercase, okay, and in in quotes, then we can come down here and we can find the layout and say capture. And really all we want, I don't need the angles, but all I really need is to say features active. If pattern equals fold, then features active, and that's here. If pattern equals fold, then it means it's true. It means that it is active, meaning that's going to be folded up. Then what we can do is we can just copy all of that. Let's go down to bottom line. If pattern equals unfold, case sensitive, then it's false. And we have to end this with an end if. Now, I know there's many other ways of doing it, but this is, for what we want to do today, this seems to be one of the better ways, okay? At least my thoughts. We close out of this, and now if we say unfold, yes, fold, yes. So now we're controlling that. And done. Let's pick. My next option would be, what if I don't want LOC miters? Sometimes I do, sometimes I don't. Sometimes I want this version, sometimes I want that version. So again, more control of a simple model. So we take a look at where we did those cuts and joins. Okay, those are here, extrusion 8, extrusion 9, extrusion 10. So what I can do here is I can say LM1, LOC Miter 1, LM2, LOC Miter 2, and LM3. The naming conventions really don't make much of a difference, just as long as you know what they mean. But if I now go over here and suppress these, you can see that that LOC miter's gone. So what I want to do then is possibly do a similar situation. So I'll go into parameters, I'll add a text field, and this is going to be LOC Miter. And I'll say yes. Make it a multi-value field, no. So it's yes, no, and pick OK. So you can see here that now we have this option. Obviously, this could have been a true-false field, but maybe we're going to do some more with this downstream. I'm not sure, but again, there are multiple approaches. I'll pick done. I'll go into iLogic. I'm going to say go to the form, edit, bring LOC Miter in, and pick OK. Well, before I pick OK, I want to put a space there. So it looks a little cleaner over here. So now LOC Miter is an option, but of course it's not hooked to anything yet, so we need to hook it to something. And I'll pick done or move on. Okay, so the next thing is to write the rule. So for this to now be implemented within the dialog box, we have to write a rule. So I'm going to create a new rule. I'll call it LOC Miter. And similar to what we just did, we'll do an if-then statement. And if LOC Miter equals, obviously you have to use a quote, yes, then let's go down to LM1, capture 1, LM2, capture, and LM3, capture. Okay, LOC Miter 1, 2, and 3, which we changed in the browser over here on the right. It puts notes in here, you know, that's what you have the apostrophe. Do we need them? Sometimes it's nice to see where it's coming from, and it helps explain the code a little bit better. I don't need to change, you know, some of these other things. Okay, all I really need to do is say features active equals true. Okay, I can take all of this, Control C, paste it, and say if LOC Miter equals no, then these are false. Control C, Control V, and paste it in, and end it with an end if. and pick Save and Close. So let's see how this works, if it works. Pattern unfold, yes. Fold it. LOC Miter, no. Yep. LOC Miter, yes. Unfold. LOC Miter, no. Works pretty good. Okay. Works pretty good. Let's back it up and fold it. And pick and save our work. So now that we've created this, I want to use this in the real world, okay? I want to bring this into cabinets. I want to use this as shelves. I want to use this as rails. I want to use this whatever purpose that we might have. Maybe it's going to be just for columns, okay? Simple columns. Or for beams, decorative beams. Hundreds and hundreds of uses. Okay. So I'm going to open up an assembly that I had been working on, and I'm going to want to use it in this assembly. So I'm going to take this door and turn the visibility of the door off, and also the visibility of, let's say, these two bottom drawers. And right now this is a 3/4 inch shelf, but I want it to be media. I want it to be 2 inches or 3 inches. Or I need it supported differently. And I'm going to use what I did in this variable miter folded part to build shelves. So I'm going to turn this shelf off, and let's measure this cabinet. So the distance from one side wall to the other is 21 inches. Okay, let's go ahead and do the same thing on the right side. From here to there, that's 18.75. So those are the two dimensional values that are important. And then I'm also going to say the depth of the cabinet is 23 inches. So it's a 23-inch depth. So if we were going to put in a shelf here, the width of the shelf, let's say we want the 1/8 inch clearance on both sides, that should have been 20.75. That's the width on this side, and the width on this side would be 18.5. So those would be the two. And 21-inch depth, well, I'm going to, let's take 2 inches off of that because of an inset door. So the depth of the cabinet will be 21 inches, 21-inch depth. Okay, now that we know approximately what we want, I need to put a shelf in left and right using the same item, the same part, even and not affect it, not by putting one in, it doesn't affect the other. So I won't use place, but I'll use place iLogic. I'll find the variable miter folded part. The major difference is I'm using place by iLogic. When I place by iLogic, you'll get 3 windows in your world. Window 1 is the assembly. Window 2 is the part that we're bringing in, the variable part, and number 3 are the values. Remember what I had done? I had clicked on key fields, and that's what's showing up here. So the first thing to consider is leg 1, which will be the top of the shelf, is not 6 inches, okay? The depth of the cabinet is 21, so I'm going to want that to be 21 inches. And you can see that this is just changed to 21 inches. Leg 2, which is going to be what demonstrates itself as the thickness of the material, is set to 2 inches right now. And if we wanted it to 3 inches, you can see it's changing in the dialog box over here on the left-hand side, or the window. Leg 3, I'm only going to go 2 inches back, save material, and the overall length of this is going to be 20.75. 20.75. And it won't have a LOC Miter. You could see that it went away. And if for whatever reason I want it unfolded, of course I could have it unfolded now or whenever. Okay, I pick OK, and I bring it in, and pick OK. So what I now have is the first piece brought into the system, and I'm going to constrain it. Now there's quicker ways of doing this, but for what we're going to do today, that's fine. And we're going to say that this side here, okay, is 1/8 of an inch from that wall, 125. Let's look at it from a front view, and you can see that the clearances are perfect, okay? And I just have to put the shelf pins in. Nice clean edge. It looks like a solid material, and I saved a whole bunch of time and expense. And this won't warp on me. Okay, let's do the other side now. I'm going to say place, iLogic. I'm going to grab the same item, exactly the same thing as I had done before. This time I'm going to keep the LOC Miter. I'm going to say the length of it is not, it's 18.5. Okay, so 18.5. I'm going to say that the leg, the top leg, is not going to be 23 inches in depth. Okay, I'm going to say it's 18 inches in depth. So I'm changing this just to show you that we can. And what else do we want to do? Let's say this leg here is going to be 1 inch. And pick OK. And place it. So this one has a LOC Miter. That one doesn't have a LOC Miter. The measurement on this is 18.5, where the measurement on here is 20 3/4. So what's going on here is I'm using the same library part over and over again, and it has different values to it. So this is build at will. Let's make that 1/8 of an inch, 0.125, and hit cancel. Looking at this now, you could see here is shelf A and shelf B. Now you say to yourself, well, you know, this shelf B is too thick. I want it to look thinner. So all I have to do is double click on it, go into miter folding, and change the leg, this middle leg, from 2 inches to 1.5, and pick done. So I'm now adjusting that leg. So what's going on here is that from the one library part, I can create infinite variations of it with infinite variability that you might consider. Okay, so as we look at possibilities, the sides, the top, all can have the same kinds of conditions applied to that if we want. Now, I've only done a 3-sided part. That's all I presented to you. But I'm going to go to a 6-sided part that I've just created. It's more of the same, but if we take a look at this, it's a little bit different, okay, than what I've done before, because I've got miters all the way around, and it's on 1, 2, 3, 4, 5, 6 parts. In something like this, everything's adjustable, okay? It's overall now. So if we say the length of this is not 90 inches, it's 70 inches. It's 70 inches because I'm not really thinking of it as a flat. I'm thinking of it as a folded part. Well, it's a box. It's a true box. So if we look at this, let's just look at it in a half section. you could see that in section, it's all mitered. It's hollow, of course. And it gives me the ability to change. Now, again, the thickness of the box, 3/4, the depth, the width, the length. And if I say, if I want to change the depth of the box to 18 inches, 18 inches is a perfectly hard edge box. If we want to change the width to 22, of course, all of that's happening. And then when I do an unfold, it's unfolded. What's also interesting about this is I can start with a 6-panel box and say, you know, I just want 2. So even from multi-bodies, I am now controlling what bodies I see. So that 3-sided unit that I started with today, that could have been a 4, a 5, a 6. It could have been an octagon. Again, it's a matter of what makes the most sense for the kind of work you're doing. If we go back to the assembly, we have the ability now to control each of the shelves, or if it's a rail or a stile or a panel, totally independently, or they could be linked together. So if you change one, it changes the other, just as a normal part would be. They can be copied and pasted, just like any other part. But the benefit that we always saw when we develop in this fashion is that if I select a shelf and sketched on it, and then drew whatever sketch and did any kind of feature, it would only affect that one shelf, none of the others. So some dramatic benefits in the way that you create, so that you can do these things on the fly. Thank you for attending our session today. My name is Steve Widom, representing Widom Associates. This is the 3rd seminar in our 2018 presentation series, focusing on the wood industry, specifically using Inventor and Woodworking for Inventor. Any feedback would be greatly appreciated. You could get in touch with us at our email address or phone number. Thank you once again.